Alright. Hello, class. I hope you're doing well. I hope your families are doing well. Unfortunately, we have to teach from home. You guys are going to have to learn from home. I know that this is going to be a bit of an adjustment, but hopefully we can get through this pretty okay. Okay, so oops. Polynomials, roots, and complex numbers. We're going to start to be looking at polynomials, which is just functions, which you guys are actually pretty familiar with already, just not with as many terms. Roots are just the solutions to those polynomials, and complex numbers is part of what we're going to be looking at the beginning. Okay, so first TICS. For Algebra 2, this will be 7A, which means that students are expected to add, subtract, and multiply complex numbers. Of course, you probably don't know what this means just yet. So first, let's start off from the beginning. Okay, imaginary numbers. I mentioned these before during class, but I didn't quite go into them too much. Okay, an imaginary number, usually denoted as I, is just a value used to take the square root of a negative value. Okay, since there exists no real number that when squared is equal to a negative value, I is defined to be the square root of -1. Okay, so give me a sec. I equals the square root of -1. This is what you want to take away from this. Okay, this is because there exists no number that when we multiply times itself, it gives you -1. Okay, you see, 1 times 1 equals 1. -1 times -1 also equals to 1. Okay, it's true that 1 times -1 equals to -1, but these are not the same numbers. Therefore, -1 just doesn't have a square root. Okay, mathematicians sort of needed these solutions to be there, so they ended up making a system of imaginary numbers. Okay. So next, like I said, I is equal to the square root of -1, and let's look at how we really want to look at the square root of -1. Okay. So properties. If r is a positive real number, then the square root of -r is always going to be I times the square root of r. And it follows that if you have the square root, not the square root, the square of I times the square root of r, and then you square it, you're going to get -r. Okay, so some examples here might help. Suppose we wanted to take the square root of -3. Okay, well, there's no number that can give you the -3 whenever you multiply it times itself. So we rewrite this as I times the square root of 3. Okay, this is a property that you want to remember, because anytime you have a negative inside of the square root, you don't want to write down no solution from now on. We're actually going to be writing down our answers, and this is the format that we want to write it in. Okay, now let's say that we took I times the square root of r and squared it. Well, let's make that an example using the one above. Let's say we have this. Okay, well, using our exponent rules, we know that everything inside the square root gets multiplied by itself, or gets squared. And what this means is that the square root of 3 and the square root will cancel out, so we're going to be left with the 3 by itself. But I squared is going to remain there, since I is equal to the square root of -1. Well, then I squared is equal to -1, meaning that it just gets rid of the square root. Meaning -1 times 3 equals -3. exactly what we had over here. Okay, so it's gonna get some getting used to, but we're gonna go ahead and skip over that for now. Just remember that if you have the square root of a negative number, we're going to be using imaginary numbers because there exists no value that whenever multiplied times itself will give you a negative value. Okay, so an example of when to use imaginary values. Well, we have sort of done this before. We've had quadratic equations. Okay, now here are some simple ones. Let's say we had this x squared equals to negative 13. Well, to get x by itself, I would need to get rid of that square root. Okay, I mean the square, not the square root. Sorry about that. I know that you guys get that confused too. But we want to get rid of that square. We want to get rid of that exponent. So we're going to take the square root of x. We're going to take the square root of negative 13 on the other side. Because we have an even exponent, an even integer exponent, this is actually going to mean that we're going to have two solutions. Okay. When we remove this square and the square root, this is going to leave x. But we're going to have both a positive and a negative version of our answer on the right hand side. For now, I'm just going to leave it as the square root of negative 13. Okay, now we have a negative number on the inside. We do not want that. We want to write it down as an imaginary number in this case. So we'll take plus and minus. We're going to remove the negative from the inside and write down an I in the front instead. And we leave the value on the inside as a positive now. Okay, so in this case, what this means is that x has a positive solution, I times the square root of 13, and a negative solution, which is negative I times the square root of 13. Okay, and that's one example when you might want to use one. Okay, now same thing happens over here. Let's say we took 11 away from both sides to simplify the problem. 3 minus 11 will give me negative 8, I believe. X squared will stay there. The 11's cancel out, so it stays like this. And now we do the exact same thing as we did earlier. We're going to take the square root of both sides in order to get rid of that exponent. Okay. So this is going to give us x on this side. We're going to have two solutions since it's an even exponent again. Plus and minus. And it's going to be the square root of negative 8. So therefore x equals to plus and minus I times the square root of 8. Remember that you're taking away the negative from the inside and writing down an I on the outside. Don't forget to take away the negative. Okay, basically the I is that negative and we're just putting it on the outside. That's all it is. Okay, well, x equals to positive I times the square root of 8, and x equals to negative I times the square root of 8. Okay, whenever we have imaginary solutions, one of the things that you want to remember is that they're going to always come in pairs. Okay, you're always going to have a positive one, or you're always going to have a negative one. Okay, so anytime you have a negative, anytime you have any negative, any imaginary solution, you're always going to have two solutions, two imaginary solutions. They come in pairs. Okay, so we're going to go ahead and move on. Okay, so next is, what are complex numbers? Complex numbers. Okay, so I mentioned that before with the teaks. Let's go back a little bit. You see, the student is expected to add, subtract, and multiply complex numbers. Okay, well, we went over imaginary numbers for a reason. Okay, let's see. Complex numbers. A complex number, whenever it's written in standard form, is a number a plus bi, where a and b are real numbers. And the number a is the real part, while the part bi is the imaginary part. Okay, so here's some examples. 2 plus 3i, that's going to be a complex number. 5 minus 5i, that's a complex number as well. Okay? Basically, it's just sort of like a mixed number between imaginary and real values. Okay. Okay. Well, you need to learn how to add and subtract complex numbers. It's not very hard. It's just basically two terms. Okay. You want to take a problem like this and approach it one step at a time. Either you start off with the complex numbers or you start off with the real values. Okay, but first of all, let's go ahead and get rid of these parentheses. You want to combine the like terms here. Okay, but you want to make sure that anything that needs to be distributed gets distributed. Okay. So I'm going to write down 8 minus I plus 5 plus 3I. Okay, well, 8 and 5 look alike, so those are going to be added together. 8 plus 5. And then we have negative I plus 3I. These are together, and these are together. 8 plus 5 is 13. Negative I plus 3. Well, that's a negative 1I. So it's going to be negative 1 plus 3, or 3 minus 1, which is 2. Positive 2. So it's going to be 2I. And because it's positive, it's going to be added on. Okay. So this is how you want to add your complex numbers. It's just add the real values, add the complex numbers, and don't mix them together. Okay, you might want to think, oh, it's 5 plus 3I, that's 8. And then 8 minus I, or 1I. Okay, if there's no number there, you always want to remember there's a 1 in front of it instead. We just don't write those down because it's kind of trivial. Okay, so our answer here is 13 plus 2I, that's it. Okay, and then let's look at the next one. Okay, so we have 7 minus, well, let me erase that a little bit. I'll write it down again. What was it? 13 plus 2I. Okay, and now for the bottom one, let me change colors. Okay, so we have 7 minus 6I minus 3 minus 5I. Okay, so here we want to get rid of the parentheses again. Okay, 7 minus 6I. That stays the same. But then right here we have a negative. We have a negative that's going to be distributed to the 3 and to the negative 5I. So this means that this is going to become minus 3, and then negative times a negative becomes a positive, so that's going to be plus 5I. Okay. So we have 7 minus 6I minus 3 plus 5I. You want to combine all the like terms, the 7 and the minus 3, and then the i's, the imaginary parts. Okay, 7 minus 3 is equal to 4, so that's going to be 4. Minus 6I plus 5I, well, negative 6 plus 5 becomes negative 1. So we can write down minus 1I, or we can just say 4 minus I. You don't have to write down the 1 there. This is going to be our final answer. But I want you guys to be worried about whenever you have a negative in front of parentheses. Okay, this is always going to change the sign of whatever's inside of the parentheses. So you want to be careful about that. Okay. Finally, oh, we have another one, sorry. All right, well, let me erase this part real quick. 4 minus I, that's our answer. 4 minus I. Okay, let's change the color to green. Okay, so 10 minus 6 plus 7I minus 2I. Well, again, we want to do the same thing as before. I'm going to go ahead and write that down over on this side since I'm running out of room. So 10 minus 6. I'm getting rid of the parentheses now, so I'm going to change the sign on the inside of that parentheses since that negative distributes. Okay, so we have minus 6 minus 7I minus 2I. 10 minus 6 becomes 4. Okay, don't get it confused with the minus 7, don't get it confused with minus 2I. And then we combine these two as well. Negative 7 minus 2. Okay, they're both the same sign. Therefore, you just add up the values and keep the same sign. So 7 plus 2 equals to 9. Because they're both negative, they stay negative, and we have that I on there. So this actually becomes, 4 minus 9I as our final answer. Okay. If you have any questions about this, please let me know. Remember, you can message me on Microsoft Teams. You can message me on Remind. You can message me on the Hub. You can try to email me. I'm going to try to reply to everyone as fast as I can. But if it takes me a little bit, just wait for a little bit. I might not be at my computer. But I'm going to try to be, well, I'm staying at home because of the quarantine as much as I can. Okay. All right, so let's move on. Okay, so this is adding and subtracting complex numbers. Remember, adding, basically just adding. Just make sure that you add the correct terms with each other. Subtracting, this is a little bit more tricky because you have to distribute the negatives. But basically the same thing. And then next is multiplying complex numbers. Okay, now this one's a little bit more different. You are going to use the distributor property here. So anytime you see something like this, you actually do want to distribute. We have 6i on the outside, so we're going to multiply that onto the inside. 6i times 4, and then 6i times 3i, and that's going to be plus 6i times 3i. Okay, now 6i times 4, you just want to multiply the numbers out. 6 times 4 is 24. And then because we have I, we're going to leave that on there. And on the other one, we have 6 times 3. You want to multiply the numbers first. 6 times 3 is 18. And then I times I, that's going to be I squared. But this is a little bit weird because you don't want to leave I squared. Anytime you have I squared, you want to remember this. It equals to -1. Okay, because remember, the square root of -1 equals to I. So if you square it, then if you square both sides, then you should get -1 once you cancel out the square root. Okay, so we have 24i plus 18 times -1. Okay, 18 times -1 becomes -18. So this becomes 24i plus -18. I don't like the way that looks, even though it's correct. So I'm going to move the -18 over to the front. Because it's a positive 24i, I'm going to make it plus 24i. Okay. But remember, make sure that they keep the same sign. If it's positive 18, then you would want to keep it as a positive 18. If it was minus 18, then you want to keep it as a negative 18. If it was minus a minus 18, then the two negatives cancel out. Okay. Now, that one's an easy one. That one's just distributive property. You kind of already know that. But this one, the next one, this one's a little bit more different. Okay. I'm going to go ahead and do this using the box method. We have 9 minus 3i and 2 plus 7i. Excuse me. I'm going to use the box method for this one. Okay, so 9 minus 3 will go on top. 2 plus 7i will go on the side. Okay, now this is a positive 7i, so I'm going to leave that on there. You don't need to keep the sign, but you do need to keep it for the 3i. And now you're just going to multiply. You're going to multiply the top with the left-hand side of the boxes. So 9 times 2 becomes 18. 2 times negative 3i becomes negative 6i. 9 times 7 becomes 63i. And then negative 3 times 7 becomes negative 21. And then we have I squared here. But remember what I said, I squared is just equal to -1. So we're going to go ahead and rewrite all the terms inside of the boxes. 18 minus 6i plus 63i minus 21i squared. Okay, so we have 18. I'm going to combine the like terms, meaning these. Negative 6 plus 63 becomes 57. I. And then minus 21 times -1 for that last term. Okay. Negative 21 times times -1 becomes positive 21. So that's going to be plus 21 there. 18 over here plus 57i. And if you notice, now we have three terms. Fortunately, this term and this term are now like terms, so we can combine them together too. This is going to become 39 plus 57i. Okay. So it worked out quite well. This is our final answer for that one, multiplying it. Let me change the color so that it's easier to see my solution for the next one. Well, the next one actually follows the same process. We have two complex numbers that are wanting to be multiplied together. So we're going to draw our box method. Okay, you can always use FOIL for this, but it's really up to you. I find it a bit easier to do this whenever using box method, whenever you have imaginary numbers, just because that I squared is going to help you remember that it's supposed to be a negative value. Okay, like these two are the same terms, and then these two are the same terms, so you want to combine them together at the very end. So we have 1 plus I. Oh, and by the way, the order here doesn't really matter either. So I could write down 3 plus 7i up here on the top, or I can write down 1 plus I. It doesn't quite matter. Okay. Yeah. Let me change back to blue. Okay, so 1 times 3 becomes 3. 3 times I becomes 3i. 1 times 7i becomes 7i. And 7i times I becomes 7i squared. Okay, so I'm going to go ahead and rewrite that again. 3 plus 3i. These are all positive, by the way. And then plus 7i squared. Okay. They're all positive, so they're all being added together. If they were negative, then you subtract them instead. Or you can just add a negative value. It doesn't quite matter. But let's go ahead and combine the like terms. 3i plus 7i becomes 10i. We have 3 in the front, and then that's 7 in the back. But because we have an I squared, this becomes negative 1 instead. 7 times negative 1 becomes negative 7, so I'm going to write down minus 7 there instead. So we have 3 minus 7 plus 10i. Notice the way I said that. I said the real terms first. 3 minus 7, which actually becomes negative 4. And then plus 10i. That's your final answer there. And that's it. That's how you multiply complex numbers. Okay. Now, if you need to go back to look back at these, go ahead. Take this time to learn at your own pace. If you have any questions, like I said, just send me a message. I'll try to get back to you. I'm going to leave you guys with some work to do. All you have to do is send it to me on Remind. I want you guys to write down your answers on a piece of paper, or do it on your phone or on your computer. It doesn't quite matter. I want you guys to show me your work. Send me your answers. Send them to me through Remind or Teams. And make sure to make sure that you sign up for both of them. Okay, if you're having trouble and don't know how to get to me, then just make sure to go just send me an email. My email for school is my first name dot my last name at houstonisd.org. These are your problems, just 3 of them. Add the following complex numbers, and then 1 more. 3 where you're multiplying complex numbers. Okay. I'm not too worried about deadlines for now, but as soon as I figure out how we're all supposed to do this, I'm going to start being a bit more strict about this. You guys stay safe, and